Good morning. I would like to present Thomas Schmid, who's going to talk about safeguarding soils for a sustainable future. He is a researcher at CIEMAT, which is the Research Center of Energy, Environment and Technology in Madrid. So I will leave you with him to talk about this amazing topic.
Okay, thank you very much, Natalia. And also thank you very much for the invitation to give my talk. I will just share my talk now. Can you see it?
Yes.
Okay, and it's on presentation mode, isn't it?
Yes.
Okay, well, again, thank you very much for inviting me to your workshop. Very interesting, what I've heard so far, and very important topics have been brought up so far. My talk will be about safeguarding soils for a sustainable future. And I'm a researcher at CIEMAT. My specialty is soil science. I've been working in different areas in the world, especially in Spain, of course, where I live. But also I've been studying soils right up to Antarctica. So I've seen soils in different situations, also in mountain areas. So it's a topic of great importance, not just for me, but for us in general. As you can see here in the first slide, you will see a very thin layer, which we call soil. It's soil in the sense of pedology, where we are looking at soil characteristics, actual processes which define our soil. And as you can appreciate, it's a very thin layer, which is on top of normally sediment or can be on rock, etc. So my talk will concentrate on what is soil, the soil functions and degradation, global change drivers which influence them, the available strategies which exist nowadays, some experimental work which we carry out, and some concluding remarks. So what is soil? When we look at soil, we see the surface, and it's normally not very compact. It's of minerals, organic matter, has liquid, has gases, and it occurs on the land surface. It's normally characterized by a series of horizons, which in general one can define as organic at the surface, then different layers going into the subsoil, representing different substratum until the bedrock, as we see here in the figure. Really, what we have is life in the soil, especially below the surface. And as we can see, or according to FAO, a teaspoon of healthy natural soil can contain more microorganisms than all the population in the world. So it's to give an idea of how lively a soil can be. And of course, it has many different functions, which we'll go into. As we see, here's a picture of a soil surface, an agricultural area, and we can stand on this soil. It supports us with no problems. But what is important is what's beneath the soil. We can appreciate here different tones of soil cover. Actually, what it's giving us is an idea of some of the soil horizons, underlying soil horizons, which have come up to the surface. This is for us as a first indication of soil erosion. What's happening here on the slopes is the top soil layers are eroding and are being displaced to the areas of depression. And like this, we have a movement of soil sediment. What happens here is the actual structure of the soil is being lost. This is being displaced and it's just being accumulated in the lower regions. So this is already an important aspect when we're considering how is the soil. When we look at the aerial view, we can appreciate this even more. We see a mosaic of different soils coming together. And what's happening is, again, the soil surface layers, horizons are being eroded, and the lighter horizons are actually much more associated to the bedrock, whereas the darker reddish colors or the darker organic horizons are still intact. However, it's concerning because this is farmland, which is producing cultivation every year, and the cycle is really using up the soil at a rate which is faster than the soil can actually recuperate. So what affects our soils in our environment? First of all, it's clear that demographic pressure is ever increasing. We have a population of over 7 billion. By 2050, it will be calculated to be around 10 billion. The population migration to urban centers, that also means that rural areas are being abandoned. There's an overexploitation of natural resources and also highly fragmented landscape. There's a high spatial variability, and this is caused by ever more construction, ever more changing, maybe highways are being constructed, etc. So it divides the land. It actually divides the important ecosystems and the biodiversity. If a road is constructed, it actually stops organisms, fauna, to be able to connect to different areas, and it creates islands which become isolated. There are a huge variety of ecosystems, all different functioning, and ecosystems are often highly vulnerable. Complex land management patterns are also often the cause that the land is degrading. And of course, we have the influence of climate change and our economic situation, which is highly variable, and as we see nowadays can change within a very short time. So there's a need to conserve and recuperate soils. We need to determine what is the potential soil capacity, have a detailed characterization, know what our soil really is and understand how it works, and to identify and monitor trends, what is happening if soils are degrading or can be improving. That also means we have to work at different scales. If we look at the soil functions, we have very many different types. That can be from climate regulation, nutrient cycling, which is very important when we're thinking of the farming. It's a natural habitat for many organisms, but not just for microorganisms, macroorganisms, but also for animals. It regulates flood. It's also a source of pharmaceutical and genetic resources. Nowadays, soils are being used to produce new medicines. It's the foundation. It's able to support human infrastructure. If this is not intact, then we cannot build on it. There's a huge problem, for example, in the polar regions with the permafrost, the stability of the ground, that's also changing. It's a provision of construction materials. It includes our cultural heritage. Normally, when civilizations disappear, they disappear into the soil, but they're conserved there, and we can find them, dig them out, and further appreciate them. It's also a provision of food, fiber, and fuel, and very important, it's a source of carbon sequestration. And the last one, which is here in the figure, is the actual water purification and soil contaminant reduction. Now, soils are capable of a lot of functions, but they have to stay healthy. If they do not stay healthy, they cannot carry out all these functions. And the more they're used, the more they're degraded. There comes to a point when the soils just don't have any functions left. So soil management and restoration are key issues within the framework of the 17 UN Sustainable Development Goals. These are something which I'll come in afterwards. If we look at the main types of soil degradation, we can separate them with the human-induced and the natural ones. The human-induced are probably the ones which most affect soils nowadays. And they are being affected at a rate because of agricultural activities, the urban areas increasing, the cities are becoming mega cities, inclusive many areas where cities have taken in small villages surrounding these areas. The industrial land, they all have their effect. And we arrive at many different types of degradation, which we know nowadays. One of the most common is probably erosion, but we have compaction of the soil surface, a runoff because water cannot infiltrate. If we look at chemical soil degradation, we can think of the acidification, nutrient depletion, salinization, etc. From the biological point of view, it's also very important where we have a decline in the soil organic carbon, reduction in soil biodiversity, etc. So there are a whole series of types of degradation, which of course will diminish soil function and eliminate the soil surface. Here in these figures, I just want to point out, if we don't protect our soils, in a very short time, a soil layer can disappear. That can be within one rainfall even. That can be a matter of hours. Whereas a soil to develop will take hundreds, thousands of years. So it really is a matter of being able to preserve these soils and not carry out massive deforestation or leave the soil unprotected. The soil needs its care, and we need to understand how we can care for it. At a global and regional scale, we can see how the soil is, the degradation of soil is happening, or where it's concentrated in the world. We see here very degraded soil marked in red, and we can go over every continent and we'll see that this is a real concerning matter. If we go to the European Union, of course, we can also see much more detail of where these soils are mostly degraded or most severe. And we come to areas where normally, especially around the Mediterranean area, where soil cover due to, or vegetation cover is more lacking, or high mountain areas, so the soil is more exposed and more delicate. to any impact. And in the end, this all results to the economy, because if we lose soil, we're actually losing the capability of crop productivity and carrying out the functions of the soil. And this can convert to billions of dollars or euros a year, which we lose. Here, as I couldn't show how erosion or soil erosion is affected in Iceland, we can also see that your soils in Iceland are sensitive to any kind of change. And we can see severe erosion and extremely severe erosion can amount to 11% or 6% respectively of the total surface area. So this is concerning and an important fact where it shows that these soils need to be protected. Now, if we look at global change drivers, first, of course, is an important one is the climate change, but we also have to consider all the others, the altered disturbance regimes, species adaptation, land use change. These all are global change drivers which will affect especially terrestrial ecosystems. Now, terrestrial ecosystems are not just of individual elements or components, they're whole number of different components which come together. Now, it's important that we can detect these, we can monitor, create inventories, and make a consistent database in the end where we can see what changes are happening. This includes, of course, experiments which need to be carried out on all kinds of aspects. If we look at CO2, nutrients, abiotic-biotic interactions, and have these coordinated, not just in individual areas or site-specific. It should be a kind of monitoring system where we have different stations. This is coming together ever more nowadays with the technological facilities. Also, we're much more connected nowadays to be able to actually carry out experiments in an area and obtain the data in real time. So we can carry out a very good monitoring. Apart from that, we also need models to be able to see how the distribution of what's happening in the different parts of the world are happening. This can be at the level regional, local, global, etc. See what is happening with the population community. As we know nowadays, with the last occurrences of war, the migration can be from one week to the other, huge. Millions of people are displaced within a very short time. And this, of course, also affects or causes an imbalance to the distribution of what's happening to the different ecosystems. So here we can apply ecosystem models. We can verify all this also through paleo records, sensitivity analysis, or experiments which we are carrying out in nowadays. So important is to see the soil as part of the ecosystem. When we look here, for an example, a wetland system, a natural system, where we see also soils have their functions, but they're in interaction together with the atmosphere, with all the different spheres we can think of, lithosphere, pedosphere, biosphere, etc. Depends, of course, where it's located. And one pedosphere could interact more with a different sphere depending on where it is. But it's all coming together as an interaction between the different spheres. So soil is one of them. I wouldn't say it's the most important, but it's one of the key spheres which we should be concerned with. Then if we take effects of climate change, so exploring how natural terrestrial ecosystems respond to climate change, or how the ecosystem can be resilient to changes, can be enhanced and maybe even assist these ecosystems to be able to face the challenges of what's going to come with climate change. We study climate change on soils because of their contribution to carbon sequestration and also as an emitter of greenhouse gases. Depending on the ecosystem, this can vary, and it can be in more, also depending on the time scale or the season even, can be greater or less. So they're contrasting conditions, and these priorities can be given between vegetation, soil microbial communities, etc. We have to keep in mind that soils function when temperatures are within a limit where processes can be activated. When I work in Antarctica, for example, most of the year the soils are inactive, but once it goes over 0 degrees, water starts to flow, the soil processes are activated, and this can cause a chain of reactions, which is important for the function of the soil. So we have there a time frame where it's very limited, and in other parts of the world it can be because there's a lack of water. So soil processes, maybe during the summer in a more semi-arid climate, will also be limited. And only when the rainfalls come, these processes are activated. These are natural cycles. But what's happening nowadays with the climate change is that these cycles are more erratic. Maybe you have an abundance of water, which isn't good either. Too much water in one moment, the soil cannot absorb it. Then it causes massive runoff, and this can also erode the soils. So there's always a balance to how much of one element can influence or another the actual conditions of the soil. Now, gaining knowledge on the adaptation processes of soils and vegetation to climate change is important and has to be monitored, because what happens is when an ecosystem is unbalanced, maybe there are species, invasive species, which are more suited to the changes, whereas original species, autonomous species, have to move or find a way to adapt to be able to cope with these changes. So this can be caused by drought regimes, irregular freeze-thaw events, etc. Even human activities, when they start much greater than what an ecosystem can take, then maybe a threshold is passed where there's no return. So these are important things we have to consider and take into account. Now, there, especially in the last decade, there are many contributions of soil science, and I mention here 5 of the most important. As we've been talking, climate change, of course. Here we can see that climate change, mitigating climate change is important. Reduction of methane, nitrous oxide emissions, sequestering carbon, etc. Nowadays with technology, we can use a lot of non-destructive methods. So that means we can monitor much better from a distance using satellite systems, etc. And there's a new generation of soil organic carbon models, which take into account many more components of the soils, which give us a much clearer picture. Food security, a shift from using soils as a substrate to produce food we used to produce at a scale food and just thought that soil would not run out, as we would say, but it does. It's a limited resource. It's finite. So one has to try to combine different production systems, producing food and at the same time improving soil quality. Widespread absorption of soil restorative measures are needed to enhance soil organic carbon content and reduce erosion. With the water security, boost water use efficiency. Up till now, many times, so much water has been used for irrigation that it's depleted the water resources, the groundwater resources in many areas. This is especially common in Spain, where water resources are scarce, but they've been used to a point that certain ecosystems cannot function anymore. There are also many novel methods like wetting agents, wax degrading bacteria, all to facilitate that water can be absorbed in the soil, and also soil conditioners composed from natural and biodegradable waste products. When we look at urban development, the strategies are also to improve soil structure. Nowadays, a lot, even architects, including new designs of houses to actually produce food, maybe in a more controlled environment. But it's also important that pollination is able to be taken into consideration. And it's been shown that once urban areas are recuperated, the natural agents are there again, it improves everything, not just the natural part, but also our human health quality. And then the ecosystem functioning and biodiversity, it's transferring an understanding of soils into natural capital and ecosystem service frameworks. I've talked earlier about the functions of the soil. The soil functions when it's healthy. As soon as it becomes too contaminated, it cannot carry out these functions. So being able to monitor multiple ecosystem cycles at one time is very important. And accounting for change in soil biodiversity and functioning. New technologies have enabled gene sequencing and the informatic technologies with artificial intelligence can all be used to give us a better understanding. Now, there are many strategies which we've probably all heard of, but they're important because they're also not just at a national level, but they're over Europe or they're at a global scale. So here, nowadays, we look at the Green Deal for Europe, where we try to attain an economy for a sustainable future. And this includes not just the soil, but also our health, etc. Being able to carry on with a life which takes care of what we're doing. Preserving, restoring ecosystems, biodiversity. Very important is the farm to fork idea, where we obtain healthy food from a well-conditioned soil, which is also in a good state. And that goes to our daily diet. Accelerating the shift of sustainability and also smart mobility. It's all together. In the end, we have many aspects of our economy which should be taking into account all these different aspects. And it's also not to just improve maybe the European Union or Iceland or individual countries, but that it's seen as a global effort where everyone is included to improve life. Furthermore, we have the global strategies such as the SDGs, the Sustainable Development Goals, the whole load 17. And for the soils, even though they're not mentioned in every Sustainable Development Goal, they are in the background. And that's also important to realize, because if we don't have good agricultural food, which is related with hunger, etc., then it also falls back on the soil quality, the soil health, resilience, etc. So here in the figure, we see a whole series of strategies, and it's connected in this case with the Horizon, Europe Horizon, where soil health and food is one of the big mission areas. This is connected with the system of Copernicus, which is a whole series platforms of sensors on satellites with all different types of sensors to be able to monitor all the complex factors or parameters we need to be able to carry out monitoring from precision agriculture right through to our ecosystem, health, etc. So these things are all connected to be able to carry out a strategy which is thought to be able to improve our life on Earth. Now I would like to finally just show a few examples where we work. This is for one area where we were working in mountain soils, and we can see here we're actually looking at different sequences from the climate, lithology, topography, biology, chronology, and we can nicely see how these different soils are being affected by climate change and changes also through human activities. And being able to have such a topo sequence of soils is actually very, very good to be able to see how these soils can change and what effects are actually happening. In Antarctica, we're studying ice-free areas in the South Shetland Islands. And here we're also seeing great changes. For example, in the image we see animal colonies, penguin rookery, but this penguin rookery is actually an area where the fauna comes every year to breed. The only thing is, we can detect nowadays the contamination of heavy metals in these soils, just because the food which the penguins are taking in is afterwards excreted to areas. So there, although we always think that Antarctica is pristine, it's actually becoming ever more contaminated. And here we have different soils which we're looking at, and they can be natural, they can be influenced by the penguins, and we have different methods to actually look at the properties of soils from the microscopic scale right up to satellite imagery. So for us, it's important to be able to carry out monitoring of these areas. A further example is the actual project where we've been able to intensify production of marginal soils. The idea is to recuperate soils which have been abandoned due to rural migration to the big cities. And here again, we can actually improve these soils, and we can carry out an integrated approach for a circular economy, where we include precision farming, amendments, crop selection, infrastructure outreach, and the fostering of local economy, the renewed attraction for bringing people back to the rural areas, etc. So the concluding remarks I have to make is that terrestrial ecosystems play an important role in regulating climate, and where biodiversity and ecosystem services help us to adapt and to mitigate climate change. Here, key is the flexibility and reaction time we have. We cannot wait to nature to take this into account. We have to be there and monitor this. Having access to study the interactive processes linking pedosphere with the remaining spheres is of importance to detect changes. Sometimes it's the vegetation which reacts fast, or the water, or the soil, depends on the situation. We have new technologies, advanced data processing techniques, and many things which we can apply to monitor and keep track of ecosystem conservation and changes. There again, conservation and recuperation of lands and of soil is an important task with beneficial future aspects, especially when we're talking about circular bioeconomy. And combining, this is also an important fact, local knowledge, which is often there, and combining this with advanced technologies is a way to optimize crop production. And then bringing, of course, which is obvious, bringing together all the research, policymakers, stakeholders, and society is key for transferring the successful experimental phase to the wider use at the local and regional level. So I would just like to remind everyone that there's a World Soil Day on the 5th of December every year, which is celebrated, and they always have a topic. And in this year will be where food begins. So just to finish, and this was already said, in the last century, in the 30s, a nation that destroys its soils destroys itself. And it's something we should take into consideration. I thank you very much.
Thank you very much, Thomas, for this amazing presentation. I hope a lot of people have learned something about the soil and the soil degradation that I think is sometimes a forgotten topic and that is really important to have in mind. I don't know if someone has any questions here online or there in person. Yvonne?
I have a million of questions, but I don't want to be the only one asking. So we are in the lucky situation that I just ruin your lunch break if I ask my million questions, but I will keep it short. Thomas, thank you so much. This was really interesting. And I think it fits so well with the previous talk we had, because a lot of what we have been talking about wastewater treatment is, okay, what to do with this black gold. And it has been discussed that, I mean, I'm totally not an expert in this area, but it has been discussed that the sludge from the wastewater treatment could be a fertilizer. We have a lot of areas in Iceland where nothing grows. And Natalia recently has reached out to the Agricultural University. They have done research on using wastewater sludge in agriculture, which is maybe not the best way to use it, because in a year where you use the poop, you cannot use the crop for feeding animals or whatever. So you have to discharge the crop for a year. So that's maybe a waste of wastewater sludge. But I was wondering, we have so many areas where nothing is growing, because Iceland is one of those areas where, as you said, it takes maybe thousands of years until something where there has been a volcano outbreak, there grows something. So I was wondering, what about that? What about fertilizing areas where otherwise nothing would be growing? Is that an option, or do we risk to have a lot of bad stuff there, like with the penguins?
Well, areas where the soil is infertile, I think you have to also consider the energy which you're going to use to make these areas more fertile. I think it's always a bit of a balance. I think of the desert areas, or in areas where productivity is so low. If there's an interest and it can help local rural areas, then I think it makes sense. But in vast extensions where normally nothing does grow, it's probably difficult to activate, and it would just be so costly. So I think there's a balance. What is important is to know how the soils are, even if they're very, very fine. And in Iceland that will happen because you have a lot of glaciers. You have a lot of glaciers receding, new areas becoming ice-free. To know how those soils develop and see if there's an improvement, maybe there's more vegetation coming in, distribution of the vegetation, colonization, etc. It's to understand these processes. That's what we do in Antarctica. In Antarctica, we see that these ice-free areas are becoming ever more colonized by vegetation. And this is a sign. Once you have vegetation, then soil can actually become active and develop. So it's really a balance to see what's happening. If an area is unstable, I'm talking about the terrain which is unstable, and there's movement of the surface material, then soil cannot actually grow or develop. And the first indication is when you start to have vegetation which is able to find roots and be stable.
Thank you very much. So that would lead, I think, to another question, but I think Sean wanted to say something. Yeah. So I hand this over.
If I could just ask a quick question about, you talked a little bit about the role of carbon in the soil. Yes. When we're looking at carbons in the soil, is there any effort to sort of assess the quality of that carbon by looking at the ratios of like relatively volatile forms of carbon, like your low molecular weight compounds, as opposed to your more recalcitrant and higher molecular weight compounds like phytic acid, polyhydroxybutyrate, et cetera? Yes,
of course. And a lot will depend on what properties the soil has. I mean, again, we talk about healthy soils, etc. Many times we're also talking about soils which are able to store certain amount of carbon. The only thing is how it's managed, and there we do differentiate. When we analyze soil carbon, we do differentiate the different types of carbon. So we can have typical carbon which, as you mentioned, can be stored in the soil. And we have other types of carbon which can actually emit and be more volatile. So there is a distinction, but it all falls back to what kind of how the soil is, what kind of properties it has.
Thank you. Does anyone have any other questions?
And I can ask my second of my million questions. No, I'm kidding. It's my last question, I promise. Everyone is hungry. Another thing that popped to my mind is in Iceland, we have these two types of people, or maybe three types. Let's start with the third type. The tourists which come and say, oh, this is so beautiful, all these purple flowers, the lupina. And then we have the people, the biologists who say, oh, well, the lupina is taking up the space for our actual vegetation. And then we have the people who say, oh, I'm putting out the seeds for the lupina because they improve the soil. So you as a soil expert, are you that last type? What is your opinion on that? Because I like to think, well, we should protect the Icelandic vegetation, and there are now projects that try to get rid of lupina, but I think that's kind of a very difficult task now.
Yes. Well, I also think one should be able to protect the autochthonous species always. The only thing is, it happens, and we see it in the mountain areas where species used to be, because of certain conditions, they cannot exist anymore, and they are displaced. And that's probably what is happening also in Iceland. As temperatures start to rise, certain species cannot compete with the actual areas they're living in. So there's also a give and take between how far can you go to maintain a species and see that that it can survive. I think natural species should be maintained, and all the invasive species should be controlled to a certain extent. The only thing is, with time, even these invasive species become, or people think they're the natural species, and I think there's also the knowledge which people have, and how we transmit this knowledge. It's very important when people go and visit these places, that they actually know that maybe this species which you mentioned is actually invasive and doesn't belong here. And then maybe people have a different idea, although it looks beautiful, it has a beautiful color.
Thank you very much.